Okay, welcome guys to this Docker and Kubernetes sessions. Okay, let's continue today being day one. So let me quickly rush through the agenda what we are going to discuss. Okay, today and the next couple of days. So we're going to have interaction on introduction to Docker and of course the world of containers. Okay, understanding what are virtual machines and how actually virtual machines are different from containers. And once we understand that, we will delve into the world of containers, and then we'll understand what is Docker. We'll understand what are Docker benefits. Most of the benefits will be more or less containerization benefits, and because Docker basically is a container engine, right? So all the benefits of containerization will be available to Docker as well. We'll understand the Docker architecture and Docker taxonomy, and then what is the underlying technology that we are going to work with. Okay, we'll have a brief look at that before we start working with containers. Okay, so the concept of containers and of course the concept of working with isolated process, it all has been evolving. And when we look at Docker or containers, right, basically we say this is OS virtualization, or we say OS level virtualization. But before we understand what is OS level virtualization, right, we need to understand something called hardware level virtualization, or what we call in short as hardware virtualization. And when we do hardware virtualization, what we end up getting or what we end up having is something called virtual machines. Okay, so let's understand the concept of virtual machines. So our story of Docker Kubernetes course starts with understanding what is virtual machine, what is the role virtual machine plays in the organization. Then we'll move on to where actually virtual machines have its own drawbacks or demerits. Then we'll move on to containers. Okay, so by definition, what is a virtual machine? Let's start our discussion from that aspect, isn't it? So we expect a computer to have processing power, certain storage where the operating system as well as the applications will be stored, and then it will have RAM where the application code will be loaded, and then the CPU will fetch the instructions. I mean, with the help of operating system, it will fetch the instructions and from the memory and execute, right? This is what basically we call it as compute facility. So this is what comes to our mind when we talk of computer. Now, a physical computer is the one that you see with your eyes, and all the components are actually visible, right? You can actually see motherboard, you can actually see hard disk, you can have a look at the RAM, isn't it? So all these individual hardware components are visible to us. But when we use the term called virtual machine, okay, just like a physical machine, it will also have processor, storage, RAM, okay, connectivity with the network. All these things are there, but this is basically virtual by nature. Why do you say it's virtual by nature? Because it has been created, okay, on some kind of a physical computer. So because it has been created using software, we basically call it as a virtual machine. Remember, even though it is virtual, it actually behaves like a physical host. Okay, it has CPU, it has RAM, it has storage, everything what you expect a physical host to have, a virtual machine will have that. So it is like a computer within a computer. Okay, so virtual machine, because it's a software, it will appear like any other process. Okay, but let me tell you, the underlying hardware is divided and we end up having multiple virtual machines, right? That is what basically is the concept of virtualization all about. Now we have huge set of hardware at our disposal. We have quite powerful hardware at our disposal, and if we want to get proper return on investment, we end up creating multiple virtual machines out of that single piece of hardware. That is why we call this as hardware virtualization. Okay, technically we can say hardware level virtualization, but we end up saying hardware virtualization. So if I have to do a bit of whiteboarding and show you here, right? So imagine this is basically our underlying hardware, okay, or you can call it as the physical host, or you can also call it as the bare metal. Okay, now on that hardware we have certain software available to us which plays the role of creating the virtual machines. Okay, so that software which allows us to create virtual machines is what we call it as hypervisor. I'm sure most of you have heard about this word called hypervisor, right? And you can see here some typical hypervisor examples, like Microsoft has Hyper-V, right? Then we have VMware, Xen hypervisor, KVM hypervisor, which is bundled in the Linux kernel. there are so many different types of hypervisors. Okay, and using these hypervisors we end up creating virtual machines. Okay, now if you look at this, the hardware resources that we have been divided among these virtual machines. Okay, so one VM will get certain number of CPU cores. Okay, let's call it as, for example, VM1. It gets certain number of CPU cores, certain amount of storage, certain amount of RAM allocated to it. Okay, similarly VM2, okay, and so on and so forth. Like this we end up creating virtual machines. Remember, all these virtual machines need not be of same size or same capacity. Not necessary. Okay, if a virtual machine is not for doing powerful activities, maybe I will allocate less amount of CPU power. Okay, if a virtual machine needs to do some compute intensive activity, then obviously I will allocate more amount of CPU power to it. Okay, again based on the purpose, I will allocate the RAM which is required for it to carry out the activities. So effectively what we have done is divided the underlying hardware among these virtual machines. Okay, that is why we call it as hardware level virtualization. As this Wikipedia says, hardware virtualization is virtualization of computers. What does it mean? It basically hides the physical characteristics of a computer platform from users, instead presenting the abstract computer platform. And the result of having or doing hardware virtualization is we end up creating something called virtual machine. Okay, technically you see it says, sometimes you also call it as pseudo machine, but I guess the term virtual machine is very popular, right? And you can see here, virtual machine is not something which has been coined recently or which is in the fashion nowadays, right? This term was coined in 1960s, isn't it? And when we say I have a virtual machine, obviously we end up having all the characteristics in the form of a software based machine. Rather than a physical machine, we have a software based machine. Now the question is, why do you want to have a virtual machine? We have a very powerful piece of hardware. Okay, and imagine you are not utilizing that hardware completely, or you're not utilizing that hardware properly. Isn't it wastage of the resources there? Isn't it wastage of the investment that you did on that hardware? Right? Imagine you actually have a quite large house at your disposal and you are using only one room of that house. Okay, so are you utilizing that investment that you made? Are you utilizing that investment properly? No, right? Something similar is happening here. When you have a powerful piece of hardware, you treat it as a mansion. Okay, you treat this as a mansion, and imagine you are using only one room of that mansion. Obviously it doesn't make any sense to have investment on the mansion at all, right? You could have simply taken a small apartment for your survival, as simple as that. And moreover, you know that on a physical host, okay, which has limited number of IP addresses, right? If I want to deploy multiple applications, each accessible at its own IP address, now this is not possible if I just deploy one application on the physical machine, isn't it? So what do? You end up creating multiple virtual machines, and then you deploy an application on these virtual machines. Of course, I'm not talking just one application, maybe an application along with its dependent applications. Okay, if application along with it some helper applications, maybe I can run a web server on one virtual machine, the database server on another virtual machine. Okay, so even if there is a problem or some crash happening in a virtual machine, is not going to affect the other virtual machines, isn't it? Unless there is a critical failure at the hardware level. So you can see here in this scenario, if one virtual machine crashes, is it going to affect the other virtual machines? What do you say? No, right? Are the other virtual machines still intact? What about the applications running in those virtual machines? Are they still continue to run? Yes, in fact, and indeed they are continuing to run, isn't it? So every application is now running in its own isolated environment. One application running on a VM1 is not going to interfere with other applications running in other virtual machine, isn't it? So we basically have isolation at the OS level. So no interference between each other's process, right? No access to anything which is shared among them. They're all running in their own isolated environment. Another important aspect of virtual machines is creating and disposing of these virtual machines is real quick, right, compared to actually getting the physical hardware for our requirements, isn't it? So basically we will provision them on need basis, right? It can be created in the matter of few minutes. Use that virtual machine for your activities, and when the job is done you can terminate or discard the virtual machine and reuse that resources for some other application or some other deployment, isn't it? Imagine the development team has done its activity, has done its job. Okay, now we have to hand over the application to the testing team. Now it will take lot of time for someone to actually provision a physical host and then deploy the application in that host and then hand it over to the testing team, and then the testing team will actually start its activities, right? So what if, for example, we get this job done through a virtual machine? Okay, so either maybe if a human angle is involved, so somebody will provision the virtual machine, or if it is done through automation, which I guess many organizations do that, right? They automate the process of virtual machines, so whether it is VMware or Hyper-V, whatever, okay, with the help of running certain scripts, especially those who are from admin team will be able to relate to what I'm saying. With the help of certain scripts, right, you will be able to provision a virtual machine and then configure it as per your requirement and then hand it over to the required team. So the team will now deploy the application, get the job done, and when they signal to you that the purpose is over, the virtual machine can then be disposed. So don't you think creating and deprovisioning these virtual machines is much quicker when compared to working with physical hosts? Can we say is that one more benefit of working with virtual machines? Virtual machines give us the concept of if something goes wrong, you don't have to worry about anything. Just discard that or terminate the virtual machine and end up creating new, isn't it? So basically you are allowed to make mistakes. When you work with virtual machines, you can basically make mistakes. It's okay because we're all learning. So create it, something goes wrong, terminate it and create a new one. As simple as that, isn't it? You're allowed to make mistakes. That's one big benefit that we get in virtualization. So many organizations treat virtual machines as something like rough books. Remember when we were in school, especially school, we used to carry one special notebook which we call it as rough book, isn't it? So do all the scribbling activities or practice activities there, and when you're sure that it is correct, you make a copy of that in the fair books or the actual books which you want to present it to your teacher, right? So in many organizations, virtual machines are like those kind of a rough book kind of activity. I mean, where you are allowed to do mistakes, whatever you want to do, and then the actual deployment, it can be again a virtual machine or physical host based on the requirement, whatever. But that is what is the concept of virtual machines. Okay, and of course based on the hardware capability, we can have multiple virtual machines created on the same piece of hardware. Rather, that's the reason why organizations go for virtual machines. Okay, and of course virtual machines will have exactly the same requirements which you expect from a physical host. We already discussed about that, right? It has CPU, it has memory, it has hard disk, it has network accessibility, right? If you want, you can share the storage with other machines in the network, whether they are physical, basically bare metal, or virtual, doesn't matter. Okay, so these are some of the benefits of virtual machines. And then how do you end up creating virtual machines? I told you the piece of software which allows us to create virtual machines is called as hypervisor. There are so many different hypervisors available out there. Okay, and then hypervisors are of different types. This is not a discussion based on hypervisors, but still I wanted you to be aware of that. So let me tell you that there are two types of hypervisors. Okay, type 1 hypervisor and type 2 hypervisor. What's the difference? Type 1 hypervisor is also called as bare metal hypervisor. What you see on your screen right now, these are basically type 1 hypervisors. Okay, let me just make a note here. These are called as type 1 hypervisors. You know what are they also known as? They're also called as native or bare metal hypervisors. Okay, now these kind of hypervisors do not rely on any separate operating system, right? Whatever bootstrapping mechanism is required, so they have those things bundled in them, and once the hypervisor is ready, you can directly interact with the hypervisor and create the virtual machines. So this is type 1 hypervisor. Okay, no separate operating system needed. Got it? Then we have something called type 2 hypervisor. So what is this type 2 hypervisor all about? Type 2 hypervisor is also called as hosted hypervisor. Have you heard about this term? It's called hosted hypervisor. So as usual, we have the hardware, okay, the underlying physical hardware, and then on top of the hardware we need an operating system for the hypervisor to exist. Now this is what we call it as the host operating system. Now on the host operating system we will have the hypervisor, okay, that's our hypervisor. You know what is hypervisor, right? Basically the software which helps you in creating virtual machines. And once you have the hypervisor, this story remains the same. There you go. Using that hypervisor you end up creating the virtual machines. So this is basically type 2 hypervisor, also called as hosted. Okay, so some examples of type 1 hypervisors, as you can see here, Hyper-V, and then in VMware we have two different types. Okay, so we have basically Hyper-V. Then in VMware we have something called ESXi, if I'm not wrong, right? Somebody can correct me if that's not the technical name. Correct me, what is the technical name? ESXi. And then we have something called Xen hypervisor, right? They all are type 1 hypervisors. That means they are basically hypervisors which directly give access to the underlying hardware without the need to have a separate OS. And then in type 2 hypervisors we have something called VirtualBox. I'm sure most of you have heard about this VirtualBox. And then we have something called VMware Workstation, right? And then we have something called Parallels on Mac. Mac people may be aware of it, Parallels on Mac. Okay, and of course we have something called KVM, the kernel based virtual machine, right? So these are all falling under type 2 hypervisors. That means they actually require some operating system to exist, and then they will be installed on top of that operating system. Okay, so these are some of the type 1 and type 2 hypervisor examples, right? So we'll not discuss something beyond this because our concentration is on Dockers and containers and Kubernetes rather than type of hypervisors. So obviously when we talk about type 1 versus type 2, right? So type 1 is lightweight, okay, and type 1 is better in performance. When I say performance, I'm talking about the hypervisor performance itself. I'm not talking about the VM performance, okay? Because the VM performance depends on the amount of or the number of CPU cores allocated for it, allocated to it, and the amount of RAM allocated to it. That would decide the VM performance, isn't it? But when you talk about the hypervisor performance itself, right, which is lightweight, which is much faster, okay, and they don't need a dedicated operating system, so that is why type 1 would be preferred. No doubt about it. But sometimes we still rely on type 2 hypervisors, right? Now if you look carefully in type 1, the virtual machines which are basically existing for type 1, right, the operating system which are installed in that VM, okay, must be built for the underlying hardware. So did you understand what does that mean? So if for example my underlying operating system is, let's say, Intel AMD kind of hardware, okay, so basically let's say x86 or maybe x64 kind of hardware. So the operating system that can be installed on the VMs is again the same type, okay, which are built for Intel AMD kind of processors. But what if for example the operating system to be installed in the VM, okay, the operating system built is not or does not match with the underlying hardware? In such case type 1 will be useless. You have to go for type 2 only. Yeah, let's say you need to let's say develop some mobile application, like you need to develop an application for Android, okay, and basically you are running the Windows dev machine, okay, maybe your desktop or laptop is Windows, okay, and you want to test your application, your mobile application which is running there, which you have developed. So can you test that application without the actual physical device? What do you say? Can you test it without the actual physical device? That's correct. If you want to basically work with or test Android applications on Windows, okay, you need to install something called Android emulator. So is Android emulator the Android operating system itself? The answer is yes. Now when I say Android emulator, right, because Android is not built for Intel AMD kind of processors, right? Android is basically built for something called